You have seen these massive trucks parked at construction sites, their giant arms unfolding like mechanical spiders, pouring tons of liquid concrete into places no wheelbarrow could ever reach. But what you have never seen is the brutal, hidden mechanism inside that body, a system so powerful it pushes concrete at pressures exceeding 200 bar through 50 meters of pipeline, delivering up to 160 cubic meters per hour. This is the machine that built the Burj Khalifa, pumping concrete to a world record height of 606 meters, and today you will see exactly how every piece of it works, including the surprisingly simple object used to clean it that will completely change how you look at these trucks forever. Before concrete can move an inch, the truck itself must transform. 4 hydraulic outriggers slide out from the chassis, each powered by its own cylinder, and press down with enough force to lift all 40 tons of steel, rubber, and machinery clear off the ground. The stabilizer pads, broad, thick, and set atop wooden or plastic mats, spread this enormous weight across the job site, turning soft earth or hard pavement into a solid foundation. Operators like Rashid keep a close eye on the bubble level mounted near the cab. Even a tilt of 2 degrees is enough to risk disaster once the boom stretches overhead. A single miscalculation here, and the entire truck can tip, sending the boom crashing down onto whatever lies below. With the truck now floating above its own wheels, Rashid steps back and grabs the wireless remote. The articulated boom, sometimes called the Z-fold, begins to rise. 4 or 5 hinged steel sections, each nearly as long as a city bus, unfold in a precise sequence, guided by hydraulic cylinders thicker than a man's arm. On the largest models, the boom can reach past 70 meters, snaking over rooftops and deep into construction pits. From the ground, Rashid controls every movement: rotation, extension, retraction, each joint moving in perfect harmony. The entire system responds instantly to his commands, allowing him to position the pour point with centimeter precision. It's a moment of calm control before the real power inside the truck is unleashed. Inside the steel body, the real drama begins. The pumping unit sits at the core, a pair of massive hydraulic pistons locked in a relentless push-pull cycle. Each piston is as thick as a man's thigh, moving in perfect opposition. While one draws concrete in, the other hammers it out at pressures that can spike from 85 all the way to 230 bar. That's enough force to send liquid concrete rocketing through 150 millimeters of steel pipeline, up to 160 cubic meters every hour. At full tilt, this system moves nearly 6,400 kilograms of concrete every minute, a mechanical heartbeat that never skips a beat. But none of this power would matter without the S-valve, the unsung hero of the entire operation. Invented by engineers like Johann Jana Muller, the S-valve works like a traffic cop under impossible pressure. It swings back and forth in a precisely timed rhythm, switching the discharge port from one cylinder to the other in less than a second. Every time a piston reaches the end of its stroke, the S-valve snaps into position, sealing off one side and opening the other, keeping the flow continuous and unstoppable. If the S-valve hesitates or mistimes by even a fraction, concrete can surge backward, seals can blow, and the entire pipeline is suddenly at risk. To survive this constant assault, the S-valve is machined from hardened steel and bathed in high-pressure grease. Even the pistons themselves are capped with high-durometer rubber heads, engineered to resist abrasion from sand and gravel blasting by at highway speeds. Still, after pumping 10,000 to 15,000 cubic meters, those piston heads must be replaced. It's a relentless cycle of power, precision, and wear. Every stroke, every switch, a mechanical promise that concrete will keep flowing, no matter the odds. Fresh concrete arrives in a ceaseless parade of mixer trucks, each one backing up to the rear of the pump. The mix pours into the hopper, a steel basin bristling with purpose. Right at the center, a heavy auger blade churns the concrete, keeping sand, gravel, and cement in constant motion so nothing settles or clogs. Rashid checks the consistency, watching for the perfect flow. The hopper's mesh grate catches any stray chunks or debris, protecting the pump's inner workings from a single rogue stone that should bring the operation to a halt. The numbers here are staggering. With every stroke of the pistons, the pump can send up to 160 cubic meters of concrete per hour through the system. That's nearly 6,400 kilograms of material moving every minute, enough weight to flatten a family car in seconds. The concrete itself is dense, about 2,400 kilograms per cubic meter, and the machine never rests. On board, a water tank holds between 500 to 800 liters, ready for cleaning or adjusting the mix if needed. During the Burj Khalifa's record-setting pour, concrete was pushed to a dizzying height of 606 meters. The scale is almost impossible to grasp. What would take dozens of workers a full day with wheelbarrows. A single pump truck finishes in under 2 hours. Rashid's job is to keep the hopper full, the auger spinning, and the flow steady. But any leftover mix in the hopper or pipeline becomes a ticking clock. If it sits for more than 90 minutes, it will harden into rock, threatening to ruin thousands of dollars worth of equipment and halt the entire job. The clock starts ticking the moment the last drop of concrete leaves the hose. Anything left inside the pipeline has just 90 minutes before it turns to stone. That's when Rashid grabs the secret weapon, a bright orange rubber ball, just a bit bigger than the pipe itself. He jams it into the end of the hose, flips the pump into reverse, and suddenly the ball vanishes into the dark. Inside, it's a sprint, 30, 40, even 50 meters of steel pipe, all packed with wet concrete that's seconds away from hardening. The reversed suction drags the ball forward, scraping every millimeter clean. Operators tap along the pipeline with a hammer, listening for the hollow thud that tells them the ball is still on track. If it stops, the job grinds to a halt and the pipe is lost. But when the ball bursts out the other end, coated in gray sludge, the entire system is saved. One cheap rubber sphere, thousands of dollars in equipment protected, all in under 2 minutes. Precision isn't just a point of pride, it's a matter of survival for these machines. When a stabilizer pad lands on soft ground or a cribbing plate is skipped to save time, the consequences can be devastating. A single misjudged outrigger, just a few centimeters off level, can tip an entire 40-ton truck as the boom swings out. The collapse is sudden and violent, steel arms smashing down onto cars, scaffolding, or even workers, all because the ground shifted beneath a pad. In other cases, the threat comes from within. If the S-valve loses its rhythm or the high-pressure grease runs dry, seals begin to wear down. A mistimed switch or a worn gasket can trigger a pressure surge, sending concrete and steel fragments blasting from a ruptured pipeline. The aftermath isn't just a mess. Sections of pipe must be cut out and replaced, and work can grind to a halt for days. Each failure is a reminder. In a world where concrete hardens in minutes and every component is under siege, there's no margin for error. High above the city, a new generation of concrete pumps is taking shape, quieter, cleaner, and smarter than anything Rashid or his crew ever used. On a test pad outside Sani's research center, Dr. Li Wei stands beside a prototype pump, its diesel engine replaced by a battery stack and electric drive. With a tap on his tablet, he brings the machine to life. Sensors embedded in every hydraulic joint and piston feed data to a central dashboard, tracking pressure, temperature, and wear in real time. If a valve starts to lag or a piston seal shows signs of fatigue, the system sends an alert before a single drop leaks. Predictive algorithms monitor every cycle, scheduling maintenance days before a breakdown could even happen. The articulated boom glides into position, guided by GPS and LiDAR, landing its tip precisely where the plans demand. In dense cities, electric drives slash emissions and noise, making late-night pours possible without waking the neighbors. For Dr. Li, the real breakthrough, it's not just automation, it's peace of mind. Every safeguard, every sensor, every line of code is designed to keep concrete flowing, workers safe, and the city growing, one silent, steady pour at a time. Every day, concrete pumps quietly move thousands of tons, shaping skylines and making modern life possible. As cities push higher and faster, the precision and power inside these machines become even more vital. Behind every towering structure, there's an engineered heartbeat you'll never look at the same way again.